In this video, we will be learning about regular polygons. The definition of a regular polygon is a polygon in which all sides are congruent and all angles are congruent. So if we know that all sides are congruent and all angles are congruent, then we can find the measure of each angle. So instead of finding sums, now we can take it even further and find the measure of each angle. So here are some examples of regular polygons. We've already discussed a regular triangle. We don't call it a regular triangle, though. We call it either an equilateral triangle or an equiangular triangle. Since all the angles in a triangle add to 180, we know that each of these angles are 60 degrees. So we would take the sum, right, of the interior angles, which is 180 degrees. And then there's three angles in a triangle. So you just divide it by 3. And that's how you get each interior angle is 60 degrees. So then if I wanted to find each exterior angle, I know that each interior and exterior angle, since they're next to each other, are supplementary. So 180 minus 60 would give me that each exterior angle in a regular triangle or equilateral triangle is 120 degrees. Then a regular polygon in the quadrilateral family would be the square, because all the sides of a square are congruent and all the angles are congruent, and they all end up being 90 degrees because the sum of the interior angles in a quadrilateral is 360, and then there's 4 angles, so that comes out to 90 degrees for each interior angle. So if I wanted to find an exterior angle, I would just do 180 minus 90, and I end up with 90 degrees for each exterior angle as well. The next type of regular polygon is called a regular pentagon. So all the sides are congruent in a regular pentagon, and all of the angles are congruent in a regular pentagon. So remember that the sum of the interior angles in a regular pentagon is 540 degrees. And since there's 5 angles, if I divide that by 5, I get that each interior angle is 108 degrees. So if I wanted to find the exterior angle of a regular pentagon, I could just do 180 minus 108 to get that each exterior angle is 72 degrees. Then in a regular hexagon, all the sides would be congruent and all of the angles would be congruent in a regular hexagon. The sum of the interior angles in a regular hexagon is 720 degrees. Since there's 6 angles, we could divide that by 6 to get that each interior angle is 120 degrees. And then if I want to find the exterior angle, I can just subtract that from 180. So each exterior angle in a regular hexagon is 60 degrees. So as we kind of already mentioned, what is the relationship between each interior and each exterior angle in any polygon? They're always going to be supplementary to each other because they're always going to fall on a straight angle. And then which regular polygon has each exterior angle congruent to each interior angle? That would be the square, since each interior angle is 90 degrees and each exterior angle is 90 degrees. So the formula to calculate each exterior angle in a regular polygon is going to be taking the sum of all the exterior angles, which is 360 degrees, and then just dividing it by however many sides there are. To find the number of sides in a regular polygon, you would actually just cross multiply, right, each exterior angle over 1 would equal 360 over n. So if I wanted to solve for the number of sides, if they give me each exterior angle, when I cross multiply, I would get each exterior angle times n is equal to 360. So I would divide that then by each exterior angle. So to find the total number of sides, if they give me the exterior angle, that formula would just be 360 divided by the degrees of the exterior angle. So those are two important formulas for you to know for when we get to some actual examples. So flip to the next page to see some actual examples. So the first example says find the measure of each exterior angle. So remember, our formula for each exterior angle is just the sum of all the exterior angles, which is 360 divided by the number of sides. So in a dodecagon, that's 12. So we would just do 360 divided by 12. So each exterior angle in a dodecagon is going to equal 30 degrees. In a pentadecagon, that's 15 sides. So just do 360 divided by 15, and you get 24 degrees for each exterior angle in a pentadecagon. In example 2, it says find the measure of each interior angle. So first, we're going to find the exterior angle just because that's super easy. And then we know the exterior angle and the interior angle are sup. So the interior angle is always going to be supplementary to the exterior angle. So in a nonagon, to find the exterior angle, I would do 360 divided by 9. So each exterior angle is going to be 40 degrees. And then to find each interior angle, I'm just going to take 180 and subtract 40 from it. So each interior angle in a nonagon is going to equal 140 degrees. So it's just one extra step if it asks you to find each interior angle. Same thing with a 20gon. Let's find the exterior angle first. So I would do 360 divided by 20. So each exterior angle is going to be 18 degrees. And then to get each interior angle, I'm just going to take the supplement of that. So I'm going to do 180 minus 18. So each interior angle in a 20gon would equal 162 degrees. Now, another type of problem you may see is like number 3. If each exterior angle has the following measure, then find the number of sides in the regular polygon. So remember the formula from the front. To find the number of sides, you just take 360 and you divide it by each exterior angle measure. So all we have to do to find the number of sides, if we're given the exterior angle, is to do 360 divided by the angle measure. So 360 divided by 12 is equal to 30. So this shape would have 30 sides. Same thing with the next one. I'm going to do 360 divided by 60 degrees, and that would equal 6. So this shape would have 6 sides. Now, the tricky one is like number 4, when it gives you the measure of each interior angle and it wants you to find the number of sides, there's one additional step. So if this is the interior angle, we're going to find the exterior angle by subtracting that from 180. So I get each exterior angle is 72 degrees, and then I'm going to divide that by 360 to get the number of sides. So I end up getting 5 sides if each interior angle is 108 degrees. So same thing with part B. The interior angle is 144 degrees. To find the exterior angle, I'm going to subtract that from 180. So I get that each exterior angle is 36 degrees. So now I'm going to divide 36 degrees by 360 to get the number of sides. So this would be a 10-sided figure or a decagon. So feel free to reach out to your teacher if you have any additional questions. We'll do some more practice in class tomorrow.